Good day, everyone. Welcome to Wanies Academy. Our subject for today is physics, while our topic is pressure and volume, which gives PV equals to constant. Aim of today's lesson is for you to know the relationship between pressure and volume in gas, while objective is for you to know how the pressure of gas in a sealed container is affected by the change in temperature of the gas, and what is Boyle's law. So, gas, pressure, and volume. In the first place, we need to understand what we meant by gas, pressure, and volume. Gas is one part of matter. Yes, we have three types of matter: solid, liquid, and gas. That is gas. While pressure is the force exerting in a certain area. That's why we have pressure equals to force over area. Okay, and that is pressure. While volume is a space, right, which is the length times breadth times height of a body. That gives length times breadth times height. And that is why volume has the unit of meter cube. Because of m times n times n, we have it as meter cube. So pressure is the force exerted on a certain area, while volume is the space in which the gas is. Fine. So now the volume of a fixed mass of gas depends on its pressure and on its temperature. So what is temperature? Temperature is the degree of hotness and coldness of the body. Now we are dealing with the mass. So we are dealing with the gas. So here it is with increase in hotness or coldness of the gas itself. So the pressure produces a net force at right angle to the wall of the container of the gas. Now let's explain how pressure occurs in gas. Now this is a gas container and we have a gas in it. Okay, so now if there is a force here exerted on this area, okay, so to decrease this, now when we exert a force here, this particle in the container will try to meet those walls, collide with the walls. At that point, that's when there is what we call gas pressure. So the force exerted on the certain area, which certain area is the wall, while the force is the particles colliding with the wall, that gives pressure. While the space in which the container is, the container itself is the volume. Okay, so that's the volume of the gas. So when gas is stored in the tube and a piston is pushed into the tube, the volume of the air in the tube decreases. What does that mean? That is when we try to give a certain force exerted here and on top of the container, there will be decrease in the volume. That is, the volume at this point, when there is a force acting on it here, then the volume will be in this form. So there is decrease in volume. So when there is decrease in volume, there is increase in pressure. And that is the relationship between pressure and volume. Okay, so now to push the piston into the tube, work must be done. Now, what's the work? Remember what work is. Okay, force times distance, right? That's what work is. So energy is being transferred. What are the energy that has been transferred? We have different type of energy. Heat energy is being transferred because there is a little force acting on that volume. So energy is being transferred. So by applying that force to the piston, the applied force has to overcome the force that is caused by the pressure of the gas itself enclosed in the tube. Okay, so the particles colliding with the wall, that gives the pressure. So how do we overcome that? The pressure here to reduce the volume must overcome the pressure in which the particles in the volume are colliding with the wall. So that's what we have. If the compression did not happen slowly, now we have what we call compression and expansion. Now what is compression? Compression is when we reduce the volume of the gas. That is compression. Expansion is when we increase the volume of the gas. That is expansion. When we have this, okay, if we get to this space, that is compression. But when we get into this space, that is expansion. Okay. So now by compressing the gas slowly, the gas loses energy by heating its surroundings at the same rate as energy is transferring to it. What does that mean? That means sometimes the gas itself can gain energy from the surrounding. And what energy can it get from the surrounding, which is heat energy? That's we call it thermal energy. That is, it increase in temperature due to the environment itself. So now there is a law that governs both pressure and volume together, and we call it Boyle's law. Okay, so what does Boyle's law state? Boyle's law states that the pressure exerted by a gas is inversely proportional to the volume occupied by it, inasmuch that the temperature remains constant. What does that mean? It means that when we have pressure exerted on a gas, it's inversely proportional to that volume, to the volume of the gas. As the pressure increases, the volume decreases, inasmuch that temperature remains constant. So we have temperature that remains constant, which is K. So let's have this here. We have P equals to, now this is 1, we're not making it as the constant, which is K over V. We cross multiply to have PV equals to K, while K is the constant. Okay, so while K is the constant, so PV equals to constant, and that is what Boyle's law is. When we say inversely proportional, that is when one body increase, the other decrease. When one body decrease, the other increase. That is why it is inversely proportional. But when we say directly proportional, it means when one body decrease, the other will also decrease with it. When one body increase, the other will also increase with it. So now let's explain Boyle's laws using this diagram here. You can see, I told you that volume is the space in which the gas is, the gas particle. So here we have increase in volume. Why do we have increase in volume? Because there is a decrease in the pressure exerted on that volume. That's why we have PV equals to constant. So when we have increase in the volume, then there will be a decrease in the pressure on the volume. But when there is increase in the pressure on that volume, then the volume will be decreased. That's what Boyle's law is. So that makes it PV equals to constant. So now what if we have it in the first place that we have a gas here, there is increase in volume and decrease in pressure. Then we have another gas, the same gas at constant temperature. Same thing, we have increased the pressure so that the volume has decreased. So that makes it as, at the first scenario, we have P1, V1 equals to, at the second scenario, we have it to be equals to P2, V2. And that is what Boyle's law is. So let's have an example to explain that. So we have this question here. In a chemistry experiment, 0.002 meter cube. What is 0.002 meter cube? That will be the volume. So let's make it volume equals to 0.002 meter cube. Was collected in a flask at a pressure, that P, as pressure itself. And remember, pressure is measured in Pascal. So that's 125 kilopascal. What's the meaning of kilo? Kilo means 1,000. Okay, so that means we can represent this 125,000 Pascal. Okay, so that is the first scenario. But after that, the question says calculate the volume. That means we are gotten to the second scenario there. So V2, that's what we want to calculate. Calculate the volume of gas at a pressure. That means the same gas has gotten a pressure of 100 kilopascal. 100 kilopascal, which is 100,000 Pascal. Okay, so now, how do we solve that? We still remember the formula, which is P1, V1. That's the first scenario, to P2, V2. That's the second scenario. Both of them are equal because we have constant. So what the value for P1, that's the pressure, the first pressure there is 125,000 multiplied by the first volume of the gas, which is 0.002, equals to, what's the second pressure? The pressure has been decreased to 100,000 multiplied by V2. That's what we really want to solve for. So making V2 subject to the formula. To make V2 subject to the formula, then we divide both sides by 100,000. Dividing both sides by 100,000. Okay, so we have this. So that means V2 equals to 125,000 times 0.02 divided by 100,000. This cancels this. So using our calculator, we have 0.0025. Now the question is, what's the unit of volume? That's meter cube. Now the question will be, our first volume is 0.002. but the second volume is 0.0025. That means there is an increase there, which is this 5. That's 0.0005. So that increase shows that the pressure truly decreased. Remember, I told you, when we have increase in pressure, there will be decrease in volume. And when we have decrease in pressure, there will be increase in volume. So this shows that Pascal rule is right. All right, so that will be the end of today's class. And please don't forget to click on the subscribe button, like the video. See you in our next class. Bye.